Welcome to the only YouTube series where we will discuss Android concepts in under 15 minutes. In today's video we will learn about the Android lifecycle and about Android components. And I actually don't think we'll need 15 minutes today. So let's bring up a 10-minute timer and start this video. When users open up an application, they usually don't really close it themselves. And you can imagine that when you have 100 applications open, this can become problematic for your phone. So how does our phone deal with this, and how does your phone make sure that it doesn't crash even though we don't close our applications? Well, that is why the Android operating system keeps track of which applications are open and which applications need resources. To make the choice easy for which application needs resources, the Android operating system keeps track of the life cycle of each application. You can imagine that when you have an application in the foreground, which you're actively using, you don't want the operating system to take away resources from that, to provide the resources to an application in the background. However, before we can go into more detail on how the Android operating system does this, we need to know a little bit about the components that we can use in an application. And there are 4 to be exact. Of course, we all know that we can use an application with a front end and with user interactions. That is the component all of us use and see. However, there are also components that run in the background, that listen to operating system, or that just provide contents to a different part of your phone. So let's start at the beginning. The user interacts with your application through a component called an activity. These activities usually correspond to a specific task, such as a login window or a settings view. However, one thing to note here is that when we use Jetpack Compose, this is slightly different, because Jetpack Compose only works with a single activity instead. Whenever we have tasks or long-running background processes, we use a service instead of an activity. A service doesn't have a front end, but it keeps something running in the background independently of what the user does in the front of an app. So your user can navigate to a different screen, but a certain process keeps running. For example, in Spotify, your music keeps running on the background independently of where you are in our app, or even if you close your app, it keeps running. Sometimes our application has to wait for something to happen in another application. For example, if you want to log in using a third-party authenticator app, such as BankID, you have to log in their app, and this will send a signal to your application that you are logged in. In this case, we can use a broadcast receiver to listen to those applications from an application such as BankID. The final component is a content provider. Say, for example, you're running Snapchat and you need to use photos of your camera instead. Then you want to have a data passage between the two applications. And this is where content providers come in. All of these objects have their own life cycle. And it is important to know that the life cycles are slightly different. However, the life cycle of an activity is the most extensive and the most used by us as programmers. So that is the life cycle we will look into today. Here on the left, we see the Android life cycle with all of its states. And it's important to know that we as programmers can do something whenever any state changes. And that is why we need to understand when and where or what causes these states to change. To help this understanding, I want to use the example of a theater. Currently, there are no musicians on the stage, but soon a symphony of music will come to life. And this resembles our onCreate phase. We are calling the musicians and making sure that they are positioned in the right spot on the stage, just as our operating system makes sure that our application has the right resources to start running. Now, during the second phase, we ask our musicians to start playing music. And this is when our application really comes to life, during the onStart phase. Now, halfway through the show, the conductor decides that he wants to talk to the audience, and thus pauses the musicians, but of course those musicians will not stand up and go away. Similarly, our operating system will keep the resources allocated if it knows that the application will resume soon. For example, if we get a call that interrupts our application flow, we usually get into this on-pause phase instead of directly destroying the whole application. This means that when we want or when we come back to the application, we can directly restart. We don't have to reposition all the musicians on the stage because they're still there. And we can just ask them to start playing directly. At the end of the show, all the musicians take a bow and leave the stage. Similarly, in our operating system, the resources kind of go into the background. But Android doesn't really take them away yet. The musicians keep backstage until they are really called away to a different concert. But if this doesn't happen, they'll stay there. It is the operating system that decides when the resources are destroyed. And when this happens, we'll go into the on-destroy phase, which is the final phase of our life cycle. Now that we know when all these phases happen and why they happen, we can start to manipulate them and do specific actions during certain phases. For example, you might want to save your data before it gets lost. But if you do this during the on-pause phase, it might mean that you have to save a lot of data a lot of times, which might be inefficient. So instead, you can move this code to your on-destroy phase, which means you only have to save it once. This way, we can handle our resources smartly and be more efficient as programmers. This was a short explanation of the Android lifecycle, and I hope that you now understand how an application comes to life and how it gets destroyed again. During your upcoming examples or applications that you will make, you will manipulate these methods and phases a lot of times. And as you do that, you become more comfortable with them. I would love to hear in the comments below if you like the analogy of an orchestra, or if you have a better analogy for explaining the life cycle. For now, I will say goodbye, but join us in the next video where we'll go into a new concept in under 15 minutes.